In this video, we are going to use geometry theorems to set up and solve multi-step equations. We're going to look at two examples. In the first example, we see that we have two parallel lines and a transversal line cutting through. We are given expressions for two angles, and if we trap each angle, so trap x plus 15 and 3x minus 35 and join that together, we see that we have this backwards C pattern. So that means these two angles are interior angles, or PLTC. The interior angle theorem states that these two angles add to 180. So I will set up the equation x plus 15 plus 3x minus 35. So the two angles, you could write them both in brackets. Just to be clear, you have the first angle plus the second angle, and that is equal to 180 degrees. There's a 1 in front of each bracket, so the brackets can be dropped, or you can use the distributive property by multiplying by 1. So now we have x plus 15 plus 3x minus 35 equals 180. So on the left side, we have letter, number, a letter, a number. On the right side, we have a number. As we have letters and numbers, or like terms, on the left side, I'm going to simplify them by collecting like terms. So I see that I have x, 1x, and 3x, which gives me 4x. And we also have positive 15 minus 35, which is negative 20. And that equals 180 degrees. So I have a letter and a number on the left side and a number on the right side. So now that I have this equation that's more simplified, I want to bring all the numbers to the right side. To do this, I will add 20 to both sides. So the left side is now 4x, the right side is 200. So I have letters and numbers on opposite sides. So my final step is to divide by 4. So x equals 50. So going back to the question, it says solve for x and state your reason. So we found x to equal 50. And the reason was we set up this equation using the geometry theorem PLTC, or the interior angle theorem. The question could also say find each angle. So now that we know the value of x, we can actually substitute that value of 50 in for x and solve for each angle. So the top angle would be 65 degrees, and the bottom angle would be 3 times 50 minus 35, or 150 minus 35, which is 115 degrees. And these two angles should add to 180. 115 plus 65 does add to 180, so we are correct. In the second question, we are asked to solve for x and y, and again state our reasons. So using geometry theorems, we're going to use these three expressions to set up equations to solve. So here we can see a couple different geometry theorems. We can see 3y minus 50 and x plus 40. These two angles here lie in the straight line, so they have to add to 180 degrees because they are supplementary angles. But I'm actually not going to use that equation because I have two variables. I have y and x, and we don't know how to solve an equation with two different variables. So let's look at the two expressions with the same variable y, 3y minus 50 and y plus 30. We see they are opposite each other. So using the opposite angle theorem, I can say that these two expressions are equal because these two angles would be equal. So we'd get 3y minus 50 equals y plus 30. So I have a letter and a number on the left side, a letter and a number on the right side. So I'm going to bring all the letters to the left side by subtracting 1y from both sides. So I get 2y minus 50 is equal to 30. So I have a letter and a number on the left side and a number on the right side. So I'm now going to bring all the numbers to the right side by adding 50. So 2y is equal to 80. So I have letters on the left side, numbers on the right side. So my final step is to divide by 2. So y is equal to 40. And the reason for that is because of the opposite angle theorem, or OAT. So now that I know the value for y, I can actually find each angle. So I'm going to substitute in 3 times 40 minus 50 is 120 minus 50, or 70 degrees. And the bottom angle, 40 plus 30, is also 70 degrees. So they are equal to each other with that value of 40. So now I'm going to use the 70 degrees and this x plus 40, and I'm going to use the supplementary angle theorem to say that 70 plus x plus 40 added together is equal to 180 degrees. So on the left side, I have a number, letter, and a number, and on the right side, I have a number. When I have like terms on one side, I'm going to collect those like terms. So I'm going to highlight the two numbers on the left side. So add those together to get 110 plus x equals 180. So now I have a number and a letter on the left side and a number on the right side. So I want all my letters on the left side and all my numbers on the right side, as I already have a letter on the left side. And to do that, I need to subtract 110 from both sides. So I'm left with x equals 70. And the reason for that is the supplementary angle theorem, or SAT. So now, if we wanted to find this remaining angle here, x plus 40, we could substitute in the value of 70 for x. So that equals 70 plus 40, which is 110. And 110 plus 70 does add up to 180 degrees, as supplementary angles need to.